Now let's look at some special angles. We have seen that if you have a circle like this, and then there is a point P here with coordinate SY, depending on the angle theta here. For us to get the values of X and Y, the S coordinate is given as R, so here is R cos theta, and the Y coordinate is given as R sin theta. I hope you remember this. If that is the case, now let's come to this diagram. First of all, let's note that this is a unit circle. What that means is that the radius, that's from the origin to the circumference, is one unit. And so in finding the coordinates at various points, we are going to use R to be equal to 1. So if you come back to this relation, R will not appear because R becomes 1. So this is what we will get. So that means that any point on the circumference of this will be given as cos theta and then sine theta. Okay, this said, we shall look at the angle, the value of the angle at 0 when the angle is 0 degrees. When the angle is 90 degrees or pi over 2. When the angle is 180 degrees or pi. When the angle is 270 degrees or 3 out of 2 pi. And then when the angle is 360 degrees or 2 pi. That's what we will be looking at. Okay, so now we have our table here. We are looking at when the angle is 0 degrees or 0 rad. That is the angle here. It means that we are still on the same x-axis. We have not made any measure of any angle. It's 0. So at that point, what is the s coordinate? That is cos 0. So at that point, cos 0 is equal to 1 and sine 0 is equal to 0. Now to 90 degrees or pi over 2, our cos 90 is 0 and our sine 90 is 1. So we have it as cos 90 is 0, sine 90 is 1. Then we come to 180 degrees. Our cos 180 is negative 1. Our sine 180 is 0. So minus 1, 0. Then we continue to 270 degrees or 3 out of 2 pi. Our cos is 0, our sine is negative 1. Then we come back to 360, which is of the same value as 0, which is 1, 0. Now, we didn't see tan. Remember, we said for tan, it comes as a ratio of the two already determined ratios. So it is sine theta over cos theta. Alright, so if we take tan, sine 0 over 1 will become 0. And then 1 over 0 will be undefined, so we will not have any value for tan 0. Then we'll come to this one. It's also be 0. This one will be undefined, and this one will also be 0. I hope it's okay by you. Thank you very much. Having looked at the various trigonometric ratios and the values of some angles, basic angles, in relation to the various trigonometric ratios, there are a few more things for us to note. Now, let's look at this circle. We divide a circle into 4 equal parts, and each division is called a quadrant. Now, this is our first quadrant. This is our second quadrant, our third quadrant, and then our fourth quadrant. First, because when we start reading, we start from the positive x-axis up to the positive y-axis. Then that becomes the first division. Then this one follows as the second division, this one as the third division, and then lastly the fourth division. So that is one thing we should note. The second one, I will label the axis. So we have positive x here, positive y here, negative x here, and then negative y here. What that means is that in the first quadrant, a point in the first quadrant will come as positive x, positive y. A point in the second quadrant will come as negative x, positive y. A point in the third quadrant will come as negative x, negative y. And then here we will have positive x, negative y. Okay. Now, we said the x coordinate is the cosine of the angle. So in the first quadrant, you see that our x coordinate is positive. So cosine in the first quadrant is positive. Now, when we say first quadrant, apart from the diagram, let's remember the first quadrant with the values of the angles. So all the acute angles. So we know, let's say the angles from, if our angle is theta, then we'll say the angles that are between 0 and then 90 degrees. They make the angles within the first quadrant. Then the angles from 90 degrees, the angles between 90 and 180 degrees, they make up the angles in the second quadrant. Then in the third quadrant, you have 180 degrees. The angles between 180 degrees and 270 degrees, they are in the third quadrant. And then 270 degrees, so the angles between 270 and 360 degrees, they are in the fourth quadrant. So when I say first quadrant, I am referring to the acute angles. When I say the second quadrant, I'm referring to the obtuse angles. And then the third quadrant, I am referring to reflex angle that are less than 270 degrees. And then when I say fourth quadrant, I'm referring to the reflex angles that are more than 270 but less than 360. So let's take note of them. Okay. So with the information given on the circle, this one, we see that in the first quadrant, cosine is positive. Sine is also positive. And we know tan is obtained when we divide sine by cosine. And since both sine and cosine are positive, when we divide, the result will be positive. So tan is also positive here. Then when it comes to the second quadrant, we have negative x, which is cosine. So cosine is negative and sine is positive. So in the second quadrant, sine is positive. Now when you divide this positive sine by the negative cosine, the result will be negative. So tan is also negative. Then we come to the third quadrant. We have negative s, negative y. I hope I don't have to tell you again that sine is negative, cosine is negative. But when you divide negative by negative, you get tan to be positive. So in the third quadrant, tan is positive. Okay, I'll leave the fourth quadrant for you to determine. What would it be? I hope you identify that cosine is positive and the rest are negative. So that's a very brilliant one. Okay, so this is it. In the first quadrant, all the three ratios are positive. In the second quadrant, sine is positive. In the third quadrant, in the third quadrant, tan is positive, and then in the fourth quadrant, cosine is positive. There is a way to remember this easily, and that we use their first letters. We use their first letters to write a mnemonic. A mnemonic called CAST. CAST. So I used A in the first quadrant to indicate that all of them, because all the three are positive and we can't use the first letters from all of them. So we use A to indicate that all of them are positive. And so we read this as CAST. And please do not say, because whenever we are reading, we are starting from the first quadrant. When we say cast, it means C is in the first quadrant. No, look at it very well. C is in the fourth quadrant. So when you are reading, you start the reading from the fourth quadrant. That is when you are reading the casts, I mean, fourth quadrant, and then you come and end in the third quadrant. Okay. We are still looking at special angles. We have seen the values for the angles 0 degrees, 90, 180, 270, and 360. We also have to check for that of 45 degrees and others. So if you have a right angle triangle with angle 90 degrees, 45 degrees, and another 45 degrees, then we are sure that because this angle is 45, this angle is 45, the side here and the side here are equal. Assuming we are dealing with a side that is 1, 1. Then by Pythagoras theorem, the longest side, that's the hypotenuse, will be square root of 2. And so these are the sides that we have. And if we are using it to find cos 45 degrees, sine 45 degrees, and tan 45 degrees, you should note that because this angle and this angle are equal, we can make reference to any of the two. So we are just taking the first one to be this. The angle of the side opposite this is this side, which is 1. So cos is adjacent over hypotenuse, which gives us 1 over root 2, and which we can rationalize to obtain root 2 over 2. That's cos 45. Then sine 45 is opposite over hypotenuse, which also gives us 1 over root 2, which we can also rationalize to obtain root 2 over 2. I hope we are making sense. Then for tan is opposite over adjacent. So opposite over adjacent, that means we have 1 over 1, which is equal to 1. So if we have you have to find cos 45, you have to find sine 45, you have to find tan 45. These ones, you don't need to do any rigorous calculations. You should know them easily like this. Again, if you take an equilateral triangle and then we divide it into two equal halves, so all sides are equal, we have 2, 2, 2, 2, 2. Then if you decide to divide into two equal halves, it means that from here to the point of division will be 1, from here to here will also be 1. So when we take one right angle from it, as you see on the diagram here, then the line also bisects the angle. So the angle here will be 30 degrees, as we see here. And then the angle at this side will maintain its value as 60 degrees. And then because we used a straight line, we get a 90 degrees, which makes it a right angle triangle. So if you also have this one, the special angles we are going to deal with will be angle 30 degrees and angle 60 degrees. So what will be their values in sine, cosine, and tangent? So we are looking at sine 30 degrees, cos 30 degrees, and then tan 30 degrees. After which we will also look at sine 60 degrees, cos 60 degrees, and tan 60 degrees. Okay, so now let's look at the sine. So we look at it, we are making reference to this angle, and so our opposite where will be 1. And then our adjacent will be root 3. And then our hypotenuse will be 2. Okay. So we are referring to angle 30 degrees. That means that for sine, which is opposite over hypotenuse, we will get the value 1 over 2. And then for cosine, which is adjacent over hypotenuse, we will have root 3 over 2. And then for tan, which is opposite over adjacent, will be 1 over root 3, which we can rationalize as root 3 over 3. Okay, so that's it. Then we come to angle 60 degrees. Now the side opposite angle 60 degrees is root 3. And the side adjacent to root 60 is 1. And then the hypotenuse remains as 2. So for the 60 degrees, our sine theta is root 3 over 2. Then our cosine theta is 1 over 2. Then our tan is root 3 over 1, which makes it root 3. And that is how we get the values for tan 60 degrees, sine 60 degrees, cos 60 degrees. I hope it's understandable. So this one all of them have been simplified or summarized on this table that you see here. So we are looking at the angle in degrees as well as in radian. So we have 0 degrees, which is 0 rad, 30 degrees, which is also pi over 6, 45 pi over 4, 60 pi over 3, 90 degrees pi over 2, 180 degrees pi, and then 270 degrees, which is 3 out of 2 pi. Okay, so as we have already looked at, these are our values. So for sine 0, you have 0. Sine 30, 1 over 2. Sine 45, root 2 over 2. Sine 60, root 3 over 2. Sine 90, 1. Sine 180, 0. Sine 270, negative 1. And so we interpret it as such. All right.